Alright, so this question is called reverse integer. It says, given a 32-bit signed integer, reverse the digits of that integer. So example 1, 123 becomes 321. Second example, negative 123 becomes negative 321. And the third example, 120 becomes 21. And we have a note here, assume we are dealing with an environment which could only store integers within the 32-bit signed integer range. For the purpose of this problem, assume that your function returns 0 when the reversed integer overflows. Alright, so we're just going to have to add a simple if statement to check for this. Alright, so let's say we're starting out with 214. When it's reversed, it becomes 412. Alright, so how do we actually do this? First, we grab the last number, which is a 4. What we need really is 41 to keep this going. Alright, so what we do is multiply 4 by 10, and then you add the 1. So 4 times 10 plus 1 gives us 41. Alright, and then we just do the same thing again. We need 412. So what you would do is you would take the 41 that we now have, multiply that by 10, and then add the 2. That gives us 412. The last thing I'd like to mention before we get to the code is that this won't work with negative numbers. So all you do is look at the number that you have initially, save whether or not it's a negative number in a variable. So let's say negative, in this case it's true. Then you immediately make that number positive. So negative 214, multiply that by negative 1 to give you 214. That's a horrible 4. 214. Then you do all the calculations I mentioned above, which will give you 412. And then you reference your negative variable. Right here it's true, so since it's true, we just have to multiply our result by negative 1, which will give us negative 412. Alright, so let's dive into this a little deeper. We start off with 214, and as we said before, when we reverse it, it's going to be 412. We're going to have the variable reversed over here, and if you keep track of this column, you're going to see every step of the way of 214 becoming 412. So initially, reversed is going to be 4, then it's going to be 41, and then it's going to be 412. Alright, so let's start. Let's look at the calculations column. The first step is to take whatever's in reversed and multiply it by 10. So 0 times 10, that equals 0. Now we need to somehow grab this 4 at the end of current, because like we said in the first step, the first digit in reversed is going to be 4. So how we do that is we divide 214 by 10 and get the remainder. So we do 214 mod 10, and that'll give us 4. Now we add these two, 0 and 4, to give us 4. And that is the first digit in reversed. We're not completely done with this iteration yet. We need to also manipulate current. So we need 214 now to become 21. How do we do that? We take 214 and divide it by 10. 214 divided by 10 is 21.4, but that's not what we need. We need 21. So we'll just round it down using floor. So that will give us 21. And that's the new current. All right, so to make better use of space, I'll scroll up, and this is where we left off, with reversed being 4 and current being 21. So we do the same steps again. We take reversed, whatever's in reversed, multiply by 10, that'll give us 40, and now we need to find the remainder of when this is divided by 10 and add it to that. So 21 mod 10 will give us 1. 40 plus 1 is 41. That's then reversed. Now we need to make 21 become 2. So we'll do what we did before. 21 divided by 10. That'll give us 2.1. When we do floor, that becomes 2. So current is now, 2. Okay, final step. Again, starting with reversed at 41 and current at 2. Let's take reversed, multiply it by 10. It gives us 410. And then we'll find the remainder when this is divided by 10. So 2 mod 10 gives us 2. 410 plus 2 is 412. Let's go over to current. Same thing we've been doing. 2 divided by 10, that's 0.2. When you put it in floor, it becomes 0. When you see that current is 0 is when you stop. And as we can see with reversed, it's now become 412. All right, so let's get into the implementation. So as I said before, we need to keep track of whether the variable passed in is negative. So let negative equals x is less than 0. Next, we'll have to create the variable that'll eventually be the reversed value of x. We'll instantiate that at 0, so let reversed equals 0. Next, we'll use the variable we just called negative in order to turn x positive if it's negative. So if negative, we can also write that as if negative is true, but this is the shorthand version. So if x is negative, then make it positive. X times equals -1. Next are the steps to actually reverse the integer. So we do that by saying while x is greater than 0, whatever reversed was, we need to multiply by 10 and then add the remainder of x when it's divided by 10, x mod 10. The final step in this loop is to chop off the last digit of x. So x equals math.floor, x divided by 10. Now we'll address the part in the details where it said that the number has to be between -2 to the 31st power and +2 to the 31st power -1. And it said if it's not in between that range, we just return 0. So we'll just do a simple if statement. If reversed is greater than 2 to the 31st power -1, we'll just return 0. And then at this point, we've successfully reversed the number, except at first the number might have been negative. And if you remember from what we did before, if the number was negative, we made it positive. So all we're going to do now is check the variable that's named negative, which tells us whether the initial number was negative. And if the number was negative, we'll just make our result negative. And if not, we'll just return the result that we have now. It'll look like this. So return negative. So this is saying, was the initial number negative? If it was, take whatever we have as the reverse number and multiply that by -1. So a positive number times negative is a negative number. If that's not true, so if the number is already positive, then we just return it, reversed. All right, so let's see how we did. Run the code. Looks good. And we have the answer. All right, so we were faster than 78% of other JavaScript online submissions. So just remember that all code and the written explanation is linked down below. See you next time.